Smaller than.
Very good. So we're going to stick it into this top function right here. We have 2 times -2 plus 1. And what's 2 times -2?
-4.
Good. -4. And then we're adding 1 to that. And
-3.
Good job. Perfect, Lamero. All right. We got 2 out of 3 done. And Navre, are you here?
Yes.
Perfect. All right, so we've got 1. So is 1 going to be less than 1 or greater than or equal to
1? Greater than or equal to?
Perfect, yes. So we're going to pick this function, this bottom one that went with this domain. We have -2 times 1 plus 3. What's -2 times 1?
-2.
Yep. Why did I do that? I'm sorry. Hold on. We're going to have, oh man, -2, and then we're adding 3. And what should we get?
1.
Yeah, perfect. All right. Excellent. All right, you guys did a fabulous job. Liz, I got your message. So if your computer dies, just watch the recording later on. I hope you find a charger soon. All right. So we have done the warm up for today. Are there questions before we move on to notes? Okay, if there are no questions, I'm going to go ahead and pull out notes. So grab a sheet of notebook paper. Make sure you wrote this warm up down because you'll eventually turn it in. And we are taking notes on end behavior and even and odd functions today. Okay, end behavior should be very straightforward, and even and odd is a little bit more complicated, but I am very confident that you guys can do it. Okay. So, honestly, you guys are like moving a little bit quicker than one of my honors classes. So you guys are doing great. All right, so notes, we are doing end behavior and even / odd. And let me see who's trying to join real quick. All right. Okay, so we have end behavior and even or odd function. So we're going to start with end behavior. Okay, there are 2 ends to any function, right? There's going to be the left-hand side and we're going to kind of abbreviate that as LH. And then there's also going to be the right-hand side. And we're going to abbreviate that as RH. Okay, so those are the 2 ends that we're looking at, the left end and the right end. And the left-hand side is going to be when the x's, are going towards -infinity, okay? So this, if you were looking at a graph, your x's are on the x-axis, right? And the direction left goes towards -infinity. Okay, so when the x's are moving towards the -infinity, it's going to be our left-hand side. It's also the left side of the function. Okay, and the end behavior is going to be defined as what the f of x values approach as those x's approach negative infinity. Okay, so kind of as an example, maybe I'd have a function like this. The left end behavior is going to be this section of the function right here. And so as these x's are moving towards negative infinity, what are the y's doing? What are the f of x values? Anybody? They're going off and they're going kind of up. And if I went up forever, what value am I approaching? Anybody?
Positive infinity.
Good, yeah. So for this particular example, so in our example with the graph, as the x's approach negative infinity, our f of x's are going to approach positive infinity. Okay? So this goes with our example over here. Okay, what questions do you guys have on left-hand side, the left end behavior? Okay, if there are no questions, then we're going to look at the right-hand side. So the right-hand side is just going to be the other side. So it occurs when, so this time the x's are going to approach positive infinity. So it's asking what they do as you approach positive infinity. All right, so this would be if I drew out a little graph. Maybe I have something like this. Maybe this is the 0.3. So these are x's approaching the positive infinity. This is my f of x axis or y axis, and this is my x axis down here. Okay, so it would be whatever this arrow is doing. Okay, so what is it doing vertically is kind of what we're asking. As we're moving to the right, what is it doing vertically? Right, so it occurs when x's are approaching positive infinity, and our end behavior is defined as what the f of x values approach when those x's are going to infinity. Okay. So in this case, and I'll kind of walk us through this case, this function kind of levels off at 3. It has a limit at 3. So for this example, should have put it right up there with the other one. As x's are approaching positive infinity, my f of x's are approaching 3. Okay, it won't always be a constant number. It could be infinity. It could go down. It could approach negative infinity, kind of like this right end behavior right here. So this goes with that example. What question?
Why wouldn't that also be infinity if that's the arrow aiming up?
This one?
No,
Are
the 3.
Are you talking about this side?
Yeah.
This is the left-hand side. We were looking at the right-hand side only for this.
Oh, okay.
So, but yes, if we were looking at the left-hand behavior for this particular function, it would go to infinity. You are correct.
Okay.
Good.
Just since I saw you write the 3 down here in the S, the sample, I got confused there.
Yeah, the 3 was to note that like that's what this function is.
Okay.
Okay. Any other questions on the right or left-hand side? Okay, so that's it for end behavior. We're going to do some examples to make sure y'all get it, and then we'll move on. So example 1, I'm going to draw a function, and we're going to do both the left and the right end behavior for this function. So we're going to do the left-hand side and the right-hand side. Okay, let's see. Daisy, are you here?
Yes.
Okay, so for the left-hand side, what are my x's approaching?
Negative infinity.
Yeah, so as my x's are going towards negative infinity, and that's always going to be the statement. Okay, so for left-hand side, you always have this first piece. My f of x's, what are they going to do? So what am I doing on this left-hand side here?
They're going down.
Yeah, so if we're going down forever, what number is that approaching?
A negative.
Good, negative infinity. Okay, and let's do the right-hand side. So for the right-hand side, our x's are always going to be approaching positive infinity. What are my f of x's doing?
They're also going down.
Yeah, good. All right, so for the left-hand behavior, thank you so much, Daisy. That was perfect. So for left-hand behavior, as the x's are approaching negative infinity, my f of x's were approaching negative infinity. With my right-hand side, as x's were approaching positive infinity, my f of x's were going down. They were approaching negative infinity. Very good. All right, we're going to do another one. So for example 2, let's do this. X, Y. Let's do an absolute value function. Okay. So we're going to do both the left-hand side behavior and the right-hand side. Okay, Jamarian, are you there? Jamarian's not here. Darrell, Tyrell, send me your what you think over Remind. And you can use the abbreviation INFTY for infinity. Not that that's much of an abbreviation. Lizbeth, are you here? Lizbeth? Okay, so I'm gonna set Lizbeth aside. Let's see, Monica's not here. Oh, Elizabeth lost her charger. That was it. Let's see. Stephanie. Stephanie Martinez.
Yeah.
All right. So the left-hand side, our x's are approaching negative infinity. What are we doing on this left-hand side?
Going up.
Yep. So my f of x's should be approaching what value?
Infinity.
Perfect. Oops, that was an ugly infinity. All right. And then my x's are always approaching positive infinity for the right-hand side. So as I move towards positive infinity, what's this right-hand side doing?
Going up.
Same. So f of x's are also approaching positive infinity. Very good. Thank you, Stephanie. I'm just going to do a few more, I think, because it seems like you guys are catching on pretty quickly. Are there questions on either of those two examples? Okay, let's do something like this. Okay, we're going to have the left-hand side and the right-hand side. We'll maybe do two more. I'm going to go ahead and write the fourth example down. Oops, it got ugly quick. All right, so maybe this is 2. Okay, so